guys? My name is MrCaproni, and this is your ACT prep. Today, I told you guys I'm going to be finishing up our last conversation by talking about how we can change the equation of a trig function to change what it looks like on the graph. So without further ado, let's dive right in and keep this short. To help us today, I went ahead and created a file on Desmos, which is an online graphing calculator that allows us to really see what's going on when I'm talking through the different points today. So starting off, you can see I have the original sine function that's being graphed right here. Now, in the last video, we talked about all the different parts of this sine function. So if you want to check that out, please go back, look at that. But for right now, we're just going to specifically talk about how changing this equation changes the graph. So again, we have our sine x function right here, and we're looking at that right now. You can see we have a full period from 0 up to 2 pi. We go a little bit in the negative just so we can see how it looks on the other side. But for the most part, we're just looking at one period from 0 to 2 pi. Now, this second equation I have right here, which is going to be in red, I actually have made it so that we can change a bunch of things about that equation. So each one of these letters represents something different we could change about the sine equation. The A is if we want to multiply the entire function by a number. The B is if I want to just multiply the measurement of the angle inside by a number. The H is if I want to add or subtract a number on the inside with the angle. And the reason we do minus H instead of plus is because usually when you're looking at the inside, it goes the opposite way of what you would think. And I'll talk about that more in a second. And then the K is if I wanted to add a number to the whole equation and talking about what that does. All right. So that is actually our easiest one to kind of talk about. If I have my sine function, notice I went ahead and set A and B at 1 and H and K at 0 because A and B I'm multiplying, and multiplying by 1 just gives you itself. So that's kind of like the default. And 0, well, if you add or subtract 0, you're not actually doing anything. So right now it is set at our default sine function. So let's first look at K. K is if you add a number on the outside of the entire equation. Now, if you add a number, what do you think is going to happen to the graph? Well, I can just move this slider around and we can see. If I move this slider around, you can see how the graph is moving here. As I move it up, the entire graph just shifts up. And as I move it down, the entire graph shifts down. So you can see that originally our graph is going from -1 to +1, but when I shift it up, let's say up 1, you can see now we go from 0 to +2. So the full length of the graph is still 2, but instead of going from -1 to 1, adding that 1 right there shifted us up 1 to make us go from 0 to 2 instead. So let's go ahead and take that back. So that means that adding a number on the outside means that we are going to be shifting our graph up or down. Now, what about adding or subtracting a number on the inside with the angle? Now, if we add or subtract on the inside with the angle, it looks like that is actually shifting our graph to the left and right instead. Now, notice as I move this up, it moves to the right, just like how the K moving up moved us up. And as I move it down, it moves to the left. But remember, in our actual equation that I have here, there's a negative in front of the H because actually as H would be like a +3, if I did X plus 3, it would actually move me to the left 3, which can sometimes be confusing, which is why they put the negative here, because in our minds, we kind of automatically think that if you're adding something, it moves us to the right instead. So when we're looking at this, they start with the negative because it's actually the opposite of what your mind would normally think. That way, when I say I'm subtracting 3, it's actually going to move to the right like we originally had thought. So if I'm going to go ahead, I'm going to subtract 3 by making that H3, you can see my entire graph has shifted to the right 3. So again, what does the H do, adding or subtracting on the inside? That actually is just going to move us left to right. Now the next one, let's go ahead and look at B. What if I multiply the angle by a number? What does that do to my graph? Well, if you multiply by a whoa, things got a little crazy there really fast. You can see it's almost like a spring bouncing up and down, all right? Here is what multiplying by the inside does. So if I take a number and multiply it on the inside, what it does is it essentially divides your period length. All right, so remember, normally it repeats every 2 pi's. We went up, down, and then once we hit right here, we were normally at 2 pi. So if I move this back to 0, you will see that from, oh, sorry, 1, because 1's the default for multiplying. You will see that we start at 0 and start repeating at 2 pi. Well, guess what? On this case, it is much, much more squished together than that and moves in. Because here's the deal. Every time you multiply by a number, what you're doing is essentially dividing your period length. Because just like with the adding and subtracting, it actually does the opposite of what your mind would think. You may think that multiplying would make it get larger, but in reality, because we are inside the function, just like the h, it does the opposite of what you would initially think. So it actually divides it. So if it usually were a, let's see, length of 2 pi, if I divide by 2, then instead of being 2 pi, it should be resetting at 1 pi, because you just take the original period length divided by whatever it is you're multiplying the inside by. All right, so let's go ahead and reset that one. And we'll look at our last one here. What if we multiply on the outside of our sine function? Well, if you multiply on the outside of your sine function, this is where we're actually messing with what we defined the amplitude, which is how high or low the graph goes. So originally, when we are set at the 1, all right, the default, we only go from -1 to 1. In other words, the 1 that it was in there for the A is the distance from the middle to the top or bottom of our graph, all right? So that's going to be 1. So if I change that to, let's say, 5, now the distance from the middle of our graph to the absolute top and absolute bottom is a distance of 5 instead, and everything else kind of fills in. So by multiplying on the outside of the sine function, we are actually just making our graph go higher and lower, but it is still maintaining the same period. Notice it still resets at 2 pi. So that means if I want to check out something where, let's say, I want it to be skinnier and have a larger amplitude, what I'm going to do is multiply both of these and see here, if I multiply by 2, now I'm resetting. My period is only a length of pi, and I'm going all the way up to 5 and all the way down. And let's say I wanted to shift that up in the air. Remember, k is what moved us up, so we're going to go up 1, and you'll notice now that my center is up a little higher. You can see once you start combining all of these, you can change your sine function to be essentially anything you need. So let's do a quick wrap up for today. We found out that if you add or subtract a number on the outside of the sine function, that is going to move your graph up or down. We found out that if you add or subtract a number on the inside of your function, that's going to go ahead and move you left or right. We found out that if you multiply on the inside of your function, that's going to change the period of your graph. In other words, it's going to either make it more spread out or pushed together. And lastly, we found out if you multiply by something on the outside of your equation, then that's actually going to make your amplitude change and make your graph go higher and lower, but still keep that same period length as before. So remember, guys, if you liked what you saw in this video, go ahead and click the like button below to let me know. And also, if you want to keep getting videos like this, go ahead and hit the subscribe button to see my new weekly videos. Remember, my name is MrCaproni, and this has been your ACT Prep.